Okay, so let's start today's lecture. So as noticed, today I will have a brief teach about the last contents, and then you will have a quiz one. So for the quiz one, actually I planned it for the closed book exam, but after I make the questions, and then I'm worried that maybe I mean it's definitely not difficult, but because I normally see you almost half of you I didn't see you in the classroom, so I'm afraid, I mean, some of unobserved students may have some problems, so I decide to make it for the open book. Okay, so I mean, definitely it's not difficult. For the quiz, I mean, it will be open book, and then I mean, you can, as announced, you can use your laptop and whatever. And the one thing, I mean, just do not use the AI. Okay, I don't need to explain why. You are PhD, so I don't need to explain, right? So just, I mean, as you want. And then normally the time is assigned for the quiz is 2 hours, but I'm sure you will spend less than 2 hours. I mean, so I mean, if you finish earlier, then you can leave as you want. Okay, so it's very flexible. Okay, any question about the quiz? Okay, so I mean, just writing answer, and then mathematics. There are some mathematics, but it's not difficult. Definitely not difficult. So and then you can search some lecture file and some. That's all. Okay. Okay, so I first today teach about some last topic, and then we will have a break time, and then continue the quiz one. Okay, so the table is enough, right? So 5, 10, 15, 20, 30. Yeah, okay. So let's continue. So today is my last lecture, and then from the week 7, another professor will continue about the part about machine learning. Okay, and then before we start, I mean, the first one is the assignment is due today. So as you can see, assignment is not difficult, right? So it's very basic questions. So don't forget to submit it on the blackboard. Okay. Okay, so this is the brief again. So what I have teach during the last 5 weeks. So week 1 is just a build up about some basic understanding of the statistics and the probability. And the second week is about the linear regression model. And the week 3 also linear regression and some simultaneous equation models. And week 4 was about the latent variable models. So far, week 2 and week 3 and week 4, we discuss normally about the dependent variable y. It's about the continuous variable. And then last week, we are talking about some more advanced, some unique features like count data or discrete data when you're dependent variable. Okay. And then today, as the last topic, is about the discrete and continuous models. It means that in your data, y, one of them is the discrete, and then second y is about the continuous. So this is about the mixture of the previous cases. Okay. So here, this is the background why the discrete and continuous models are necessary. So normally, statistical approach to discrete logic probit, you have learned the last lecture. And the continuous, I mean, for example, the classical regression model using the OLS estimator are well established, but many real problems involve the link the discrete and continuous outcomes. Okay, so always, I mean, the real problem is always more complex than classical models. So this is why you need to publish your paper, and then there are many things to explore. Okay. So for instance, I mean, the basic example, we normally separately analyze the vehicle ownership and the vehicle usage. I mean, how many kilometers you will use, and then which type of the vehicle you want to purchase. But if we think about more broad way, I mean, actually this decision, these different Y, they are interrelated. So if these both are continuous, then you can use the simultaneous equation model you remember in lecture 3. But normally, many times, I mean, their type can be different. Vehicle ownership is like a discontinuous model. I mean, Y is a discontinuous, discrete. And then the vehicle usage is about the kilometer or miles, whatever. So Y is continuous. So these two different type of Y, they are different. So another example is on the route choice situation. So for instance, you can choose one of your route. I mean, you have an origin and between origin and the destination. You can choose arterial road, highway, and the freeway. So normally, if someone choose the freeway, their travel speed will be faster than the other one, highway or arterial way. Okay, so I will explain more detail about this. So in this example, vehicle ownership and usage, and then the choice of the vehicle type and the number of vehicles owned is discrete. Choice of the vehicle type means that the CA the small how to say small vehicle, middle vehicle, or large vehicle, whatever. And also number of vehicles, some of them they only own one vehicle or two vehicles, three vehicles in their household. And then here the continuous variable is about the kilometer driven. How many times they use it. I mean, how many kilometers there. So here there are some interrelationship. So household self-select vehicle types based on their expected usage pattern. Okay? And then they observe the mileage only for the chosen vehicles. So therefore, it is non-random sample. So it means that if I want to drive lots of time, then normally people they are likely to purchase the bigger vehicle. Okay? And then another example is about the route choice and the travel speed. I will discuss about this issue more details today. Okay, so discrete one is that the chosen route, arterial route, highway, and the freeway. And then a continuous dependent variable observe the travel speed. So normally, I mean, if I'm the driver, I want to drive faster, then normally they choose the freeway. So normally the observed speed on each route are non-random. So if we observe the speed, the average speed on the freeway, then it means that they already the sample itself is only for mostly for the faster drivers. So if we predict if a non-faster driver choose the freeway, then how can we predict their speed? So this is the main empirical issue in transportation policy. Okay. So sorry, it's a repeat. So here, why interrelationship is easy to overlook in the real problem? So common features is that data appear purely continuous, and models are only the classical regression alone. And discrete choice, I mean the number of vehicle, I mean the type of the vehicle, normally we treat it as exogenous, and then ignores the self-selection problem. I will explain more detail about this issue. And then self-selection, I mean, actually this is about the sampling. In this class, I mean, what I always emphasize based on the lecture 2. So here, I mean, always, I mean, what I emphasize in this class. So here, I mean, what we want to know is the real true knowledge. I mean, it means that. Oh, sorry. Maybe I can first download. So from the lecture file in the week 2, what we want to know? We want to know the global knowledge, I mean the true knowledge, universal knowledge. So from the real world, I mean population, all the world, there are some value beta. This is what we want to know. Okay, but we cannot get the whole data. We cannot get the true data. Why? Because it's very big. I mean, it's not possible in research. So we normally use the sample, and then we call it is the data. And then based on data, we estimate the parameter beta. Therefore, I mean, to publish your result in the good journal, they should be same. Okay, the same in academic way is the unbiased. It means that equal. So this is always an issue. So here, I mean, in this last lecture, still, why this issue is important is that, I mean, it can cause any bias. So bias means here, in this case, the self-selection bias here. Okay, so many published studies is not correct actually. And then normally they ignore the interrelationship between different variables. So what is the result? Biased parameter estimate. Always, I mean, this is the goal in my the core in my lectures in this class. And then why biased parameter estimate makes some problem? It can lead the wrong policy conclusions, wrong direction for the policy. So here for the biased estimation result, this is called the selectivity or self-selection bias. It means that sampling has some problem. So parameter do not represent the true causal effect. I mean, the beta is not beta. Okay. So let's explain more detail. I mean, more detailed example. So here, now I'm talking about the selectivity bias. Selectivity bias or self-selection bias, I mean, they are same. So let's assume freeway speed regression. Okay, so this one, so this is the Y. Okay? So Y means that average speed of commuter N on the freeway. Okay, and then the beta and X is the characteristics, I mean the attributes, and beta is parameter, and then this one is the error term. So this is the very simple regression form. Okay, and then here, what is the problem in the sampling to get the data? Here is that, as I briefly mentioned before, so here you can see. So this observations, this figure is about the true distribution of the speed. Okay, but normally what we can collect is that about this plus part. So it means that normally observed freeway users, they have a higher speed than unobserved speed of the non-freeway users. It means that we cannot predict if the non-freeway user, when they use the freeway, we cannot predict their speed. Why? Because data is about them, the faster drivers, the current freeway users. So in this case, what we want to do is about this line 2 is our goal for the regression. A mixture of the plus and minus. But normally, if we collect the data, we can only collect the data for the plus because the current freeway user. So what we want to estimate is the line 2. But normally what we have the estimation result is the line 1. Therefore, they are beta, the slope, they are different. So actually, the result of the line 1 is already biased. So this is the selectivity bias. Why is the selectivity? Because the freeway users, we can only measure the speed of the current freeway users. But when we modeling, we need to consider the non-freeway users, their speed when they use the freeway. But normally their speed is lower than current freeway users. So this is called the self-selection bias or selectivity bias. Okay. So this is about this one again. So what we want to the true. So what we want to estimate regression is the line 2. But our data is only about the plus. Therefore, we can only get the result of the line 1 if we just use the simple regression model. Okay. Therefore, why? So what is the problem here? We didn't consider their route choice. Okay, we only consider their travel speed on the chosen route for the freeway users. Okay. So for this problem, we need a discrete continuous models. So here, nature of dependent means that y is the one discrete and one continuous. And then they are inherently linked means that interrelated. Okay. And then dependence means that X is the endogenous selection, discrete choice determines, something blah, 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 any variable, explanatory variable. And then main issue, if this y prime is model separately, so selectivity bias here. Okay. And then actually my plan for this class, I want to discuss more about this part, estimation, algorithm like joint maximum likelihood, Hangman correction, MDCV. Actually, this was my plan for this class, but I think it's not possible. So just keep the naming there. So what kind of the estimation method you can use if you need to use it in your future research. Okay? And then example, I already explained it. Okay, so from now I will explain. So in this problem, if we just use a simple regression, there are some problem called the selectivity bias. Then how we can solve it, I will explain from now. So there are two methods. First method is that the instrumental variable. Instrumental variable is also called the proxy variable. Okay, so I already explained this concept in week 3 when I explained about the simultaneous equation model. It's a little bit similar. So this is the basic idea. So compare to the original simple regression model, we will have a simple correction term based on the proxy variable, instrumental variable here. Okay. So here now the S, the Y is the average speed on the commuter N, and the chosen route. So now it becomes a little bit different. Here the difference is that in this original function, in the Y, is about the SFN. F means the freeway there. So we only consider the freeway users. But here it becomes the more general. Freeway, arterial load, and whatever. Okay? And the X is the explanatory variable. And the point here is about the instrumental variable Z. Proxy variable or instrumental variable, whatever, is a vector of characteristics of the commuter N space that the influence average speed that are function of the route chosen. And then beta alpha are parameters. And then this is the error. So it's a still regression form, but the Zn derivation of the Zn is also require another regression, kind of regression model there. Okay. So here again, in this equation, Zn is the endogenous, and then correlated with the error term. So you remember multi collinearity in the regression. This is the basic assumption in the simple general basic regression model. X and the epsilon, they should be independent. But here already, because the proxy variable z is already endogenous, and then it is already correlated with the error term. I don't know what it called in English, but this one at the error term. Okay, so the general approach using the regression, the classical linear regression model is not allowed. So here, speed preference influenced the root choice, and then root choice influenced the observed variable z there. Okay. So therefore, multicollinearity is not valid. So if we directly estimate this model using the classical regression model, what is the problem? Biased. Okay. Biased is about bias. Bias means that beta is not beta. And then inefficient, you already learned variance of the estimation beta biased. Okay. So here then how we can do, we estimate the zeta, the proxy variable z together with the other parameter alpha and beta. Okay. So step is that regress on each element zn, okay, of the all exogenous variable, the explanatory variable x, and obtain predict value zn. Therefore, it should be unbiased. Okay. And then estimate the second stage model here. So it means that we doubly estimate the model. Something like that. Sorry. So now this instrumental variable, the estimation method itself is quite close to the simultaneous equation models, what I have lectured in week 3. Okay. So why they are similar? Because they also use the instrumental variables. Okay. And then here, the instrumental variable approach is normally common in the statistics. So what is the benefit? I mean, normally if we face with a complex situation like this selectivity bias, the statistical researchers, they normally first think about the instrumental variable. Why? Easy to use. Okay. Very applicable. So corrects for endogeneity if instruments are strong. If we have a good proxy variable, then it's okay. But what is the limitation? Not correct normally. There are some bias. So always, I mean, the statistical model, I always lecture even in master class or bachelor class. Normally, I mean, for the statistical or probability model, for the same issue, single issue, you normally run the multiple models. And then, of course, I mean, you can wonder why you need to learn about the multiple models. You can only learn about the most classical model, most popular model. But normally, several models, we have a trade-off between easy to use and then the accuracy. Okay. So still many general people, they prefer the model easy to use. So still you need to learn about this. But of course, I mean, you are PhD. I mean, if you get the faculty position, professorship position, then we prefer, of course, the more accurate models. So always the trade-off, accuracy and easy to use, there also. So limitations requires good instrument and can lead weak instrumental bias. First is poor. It means that not accurate, not much accurate. Okay. Then so now the IV approach is more like easy to use. Then what is the accuracy, more accurate model? It's about the second approach, expected value method. So expected value method is also called the probability weight. So the idea is that, okay, so now the basic idea is same. So we apply the new variable z is about the endogenous variable. So to consider the correlation with the error term, we decompose the expected value of z into the multiple component of the zj. Okay. For instance, here, where it is. So in this case, so in the so in this example, we have two options: freeway and arterial way. So plus is the freeway and the minus is arterial way. So in this case, we divide z to zj and z for the arterial route or freeway. And then we calculate the probability for each one. Pj prime, something blah, blah, blah. Okay. So in this case, we can extend like this regression model. So compare these two methods, core mechanism. The instrumental variable is the first stage prediction of the z. And then expected value method is about the probability weighted average of the z across the different alternative. Here in this example, it's about the different route, arterial route or freeway. And then requires and the endogenous proxy variable for the z. And then here we need a separate discrete choice model. I will explain more detail. And then handles multi-alternative. I mean, of course, something blah, blah, blah. So common in the studies, especially in transportation engineering. So expected value method is more common. Okay, and then second approach is about the selectivity bias correction term. This is the more accurate, but more complex. Complex means that it's not easy to use. Okay? So here, why we need a correction term? So observed speed are non-random due to the self-selection into the route I. So we make it as a conditional term. Instead of the S, we use the expected value of the S. And also the error, instead of the error term, we use the expected value of the error. Okay. So maybe it's a little bit difficult today, right? I mean, it's not on the quiz, so I mean you can enjoy. Okay, so actually this level what I target in this class originally. Okay, so in this case, I mean the motivation, the conditional expectation form in this way. So compare to the original idea, the original regression model here, not here. Sorry. So in this case, they use the proxy variable z. But in the second methodology, instead of the proxy variable z, we use the expected value there. Okay, this is the core idea. Then statistically more deeply, for instance, here we have a two expected value. For the error expected to calculate the expected error, we use the conditional expectation of the error term there. So it can be explained, the probability form and explanation. So maybe the detail is out of the lecture. I mean, so this is normally the expression, the expectation of the error. Okay, because error itself is about the distribution, and then this is the CDF and so yeah. Okay, so here the P is the probability and of the chosen discrete outcome I. So in this case, I means that the previous example, arterial route or freeway. Okay, so if we assume the R, the certain parameter R is the generalized extreme value distributed with the sigma square, the variance of the distribution, being the unconditional variance, the error term, and pi, the probability being correlation with the error term and the resulting discrete outcome logistic error terms. So I mean something blah blah blah, and then it's a little bit complex. But what we normally do is that we use the p for the logic. You learned before, exponential by exponential. Okay, based on assumption that maybe error term follow the Campbell, IID Campbell. So simply we assume, of course, this assumption is very strict, but still very easy to use the closed form. Okay. And then so we something blah blah blah, and then expectation about blah blah blah. Then here, the expected of the error term can be represented like this. Okay. So J means the number of alternate number. Sorry, number of alternative, and rho is the density of the distribution, and the sigma is the standard deviation of the distribution, and then blah blah blah. So selectivity bias in the discrete continuous models is corrected by undertaking these steps. So estimate the multinomial logistic model for the P to predict probabilities discrete outcome I for each observation, arterial route, and the freeway. And then use the logic predict outcome probabilities to compute the portion of the above equation here in large blanket, this part, for each observation. And then use the values to compute in step 2 to estimate the original equation using the standard least square regression models, the OLS least models. And then this term becomes a single estimatable parameter. So so in this way, this is the original form. And then for each route, we have a different S for the arterial route and the freeway. And then we can estimate the single parameter for this part. And then this part, we can treat it as a new variable based on the Z and the P. So here in this case, in the common practice, in the statistics, we fix the rho equal across the alternatives, and then impose the restriction. So we normally estimate a single rho here. But of course, I mean, the more and more flexibly we allow rho for the different alternatives, rho for the freeway and the rho for the arterial route. And then include it in the summation and estimate J minus 1 separate parameter for the continuous equation, blah, blah, blah. Okay, so in this case, so this problem again, so line 2 is the true information, what we want to know, but we normally estimate the what line 1. Therefore, there are some selectivity bias. So step 1, what we normally do, we calculate the probability, root choice probability using the MNL, the logit model. And then for each individual who choose each root I, we compute lambda. How? So based on the step 1, we can get the information about P. And then based on this P, we can calculate the lambda there. Yeah, P is from the logit. Okay, then we can get the lambda for each individual. And then now we have a lambda, X and the lambda. Therefore, we can make a regression with the unbiased beta. Okay, so this is the general approach when we talking about the selectivity bias. Okay, so I think that's all. So I mean today is the last lecture. So how to say, I mean, it's not about quiz one, so I don't I want to keep in the last moment keep my style. So maybe it's a little bit difficult for you, but maybe in your future, if you face with this issue like a selectivity bias or some discrete continuous outcome, then you can start from here. Okay. So that's all. And then if any question? If you don't have any question, let's take a 10-minute break. Then let's start the quiz one. Okay. 예. 뭐 5분 부분인데, 5분 부분인데 상관없지. 내가 컨닝하지 말라고 얘기는 한번 할 건데.